Hello, my name is Fay Almousa, and I'll be presenting about how the Galleria by OMA was created through grasshopper definitions and the physics of the kangaroo plugin. To start off, the building consists of two main parts, which are the main building and the glass skin that wraps around the stone building. Moving on to the grasshopper file, all components grouped in white reference the glass skin. The light gray references the main building, and the orange ones represent the kangaroo definitions. So with that being said, two main curves were created, one for the main building and the other for the glass skin. So for the main building, a rectangular curve was created and extruded in the Z direction, then converted into a simple mesh and deconstructed into segments. The glass skin curve, on the other hand, was modeled in Rhino, then divided into a specific amount of points. These points and the main building simple mesh are then plugged into an on-mesh battery. This battery allows the original curve, the points on the curve to attach on the building, onto the main building's surface mesh. So this is the original curve or points, and these are the points attached to the building. After that, the points on the surface mesh were extracted as an output, and the process of creating the formal language of the skin began, of the glass skin. A graph mapper was used to visualize the flat shape of the skin, which would then be inflated. This process consists of creating two offsetted curves, one for the top part of the skin and the other for the bottom part of the skin. Then a NURBS curve battery was added to create the curve itself, then finally loft both curves. Next, the lofted surface was flipped so that the normal would match the direction of the inflation. Then the UV were adjusted, joined, and also flipped. The last step of the flat surface process is using a triangulate battery to create the rigid triangles of the skin, and naked vertices were finally extracted from the mesh. And the second solver was used with a pressure strength of 0.06, which can be adjusted to create a softer inflation. This is the first inflation. And then it could be listened to make a smaller inflation or a softer inflation. Finally, frames were extracted from the final mesh surface to create the mullions holding the glass together. And for the final result, two parts were combined by extracting a mesh box from the original main building mesh. The glass skin was trimmed out of the main building to create the walkable inner space. This was created by using the skin's mesh and thickening it on both sides to split it from the main building surface. Then finally, an offset mesh battery was used to create the walls. These numbers can be adjusted so that it would create the splits in a better way. As for the final result, this is how the building looks. Thank you.